In this lesson today, we're going to talk about how we're going to solve other types of equations. So we're going to start off by trying to solve some polynomial equations. We're going to solve them by factoring and using the zero product principle. If you'll recall, the zero product principle states that if I multiply two numbers together and that product is zero, then one of those factors has to be zero. Let's see how we would apply this to number 2. If we were to solve this by factoring, the first thing I'm going to do is factor out a greatest common factor. The greatest common factor will be 5x to the second. So I'm going to divide both of these terms by that GCF. What does that leave me with? The 5's cancel out. Subtracting my exponents, I get x squared minus 4. The x squareds are going to cancel out. 20 divided by 5 is 4. I'm going to keep factoring until I've factored completely. 5x squared is my GCF. It's part of my answer. X squared minus 4 has two terms. So that's either going to be squares or cubes. This actually is a difference of perfect squares, which is factorable. My signs are always plus minus. X squared breaks down into x times x. And what number do I square to get 4? That would be 2 and 2. So this is now factored completely. So what I'm going to do after we factor completely, we're going to set each factored part equal to 0. If you'll notice that the degree of this problem, which is the highest exponent, is 4. So I really should come up with 4 answers. So I'm taking each of those factored part, I'm setting them equal to 0. So 0 divided by any number is 0. And technically, I'm taking the square root to get x. And so I'm actually coming up with 2 answers of 0. The reason I say that is just because my degree is 4. That's the highest exponent in my original problem. So I'm going to come up with 4 answers. This is like a repeated solution. Over here, I'm going to subtract 2 from both sides. I get negative 2. And here, I'm going to add 2 to both sides. So my answers are negative 2, positive 2, and 0, with 0 being a repeated solution. You want to make sure that you check all of your answers, and if we plug these back in, we'll see that we do get a true statement. Looking at number 6, I need to, first of all, get this problem set equal to 0. That's the only way that I can use the zero product principle. So, would you move 9x cubed to the left side or x and 1 to the right side? I probably would want my highest exponents to be positive, so I'm going to move everything over to this side. Still getting it set equal to 0. So if I move positive x to the right side, I'm going to do the opposite, and I'm going to subtract. So it's going to cancel out over there. If I move positive 1 to the other side, I'm going to subtract, and that's going to cancel out. So I've set my equation up to equal 0. Now I want to factor it. So I look for a greatest common factor. I do not have one. I count my terms. I have 4 terms, so I'm going to try to group it. Remember, on grouping problems that have a negative on the third term, we want to include that negative, and I'm going to put a plus sign there. If I draw my negative, on the other side of that subtraction sign, it changes the sign of the x and 1, and that's going to make my problem incorrect. So be careful when you're factoring grouping problems, and the third term is negative. So let's factor the GCF out of the first grouping. I'm going to factor the 9x squared out, and I get x plus 1. Remember, on when the third term is negative on grouping problems, we always want to at least factor out the negative 1. The GCF between x and 1 is 1, but we want to take that negative out. And I'm going to show this step. I'm dividing both of these by negative 1. This is really just changing my signs. Negative divided by negative is positive. Negative divided by negative is positive. And I know that this is correct because when I am working with the grouping problem and I'm trying to factor, I want what's left inside those binomials to be the same. So what I'm actually going to do is I'm going to refactor out that GCF. I'm dividing both of these terms by x plus 1, and that's going to leave me with 9x squared minus 1. So let's keep factoring. That 9x squared minus 1 is two terms. They're both perfect squares, and it's a difference. So I'm actually going to factor that as a difference of perfect squares. So what number do I square to get 9x squared? That would be 3x times 3x. And what number do I square to get 1? 1 and 1. I look at what's left. Everything that I have is two terms. Remember, if I can factor it further, they would either be squares or cubes. I can take a look at my variables and see that none of my x's are squares or cubes, so I'm not going to be able to go any further. So what I'm going to do is I'm going to set each factored part equal to 0. And then I'm going to go back and solve. So here I'm going to subtract 1 from both sides. 0 minus 1 is negative 1. Over here, I'm going to subtract 1 from both sides. I get negative 1. Then to finish up solving, I would divide both sides by 3. So my second answer is negative 1/3. And over here, I would add 1 to both sides and divide both sides by 3, and I get positive 1/3. You can see that the highest exponent was 3, so I should come up with 3 answers. In solving for number 10, we look and we see that the problem is not set equal to 0, so that's where we want to start. So I'm going to move the positive 81x to the other side. It's positive, so I'm going to do the opposite by subtracting 81x from both sides. So when I subtract 81x from the right side, that's going to give me the 0 I'm looking for. Do not forget the first rule of factoring. We want to factor out the greatest common factor. So we get x to the cubed minus 27. So I look at what's left. I have two terms. This time I have x to the third. So is this a problem that I can factor by cubes? 27 is a perfect cube. X to the third is a perfect cube. So remember that to factor that, I'm going to have to do the SOP method. Same sign, opposite, positive. So same sign, opposite of that sign, positive, and then we're going to go through the pattern for factoring cubes. What number do I cube to get x to the third? That's going to be x. What number do I cube to get 27? That's going to be 3. And then the pattern is that I'm going to square this number, multiply these together. 3 times x is 3x, and square the last term. 3 squared is 9. Now, if you recall, I made a statement, something about when we were reviewing factoring differences of cubes and sums of cubes, we can factor both of those, is that once you complete that pattern, you cannot break it down any further. So I'm not going to be able to factor this any further. So let's set each of our factored parts equal to 0. So the first one is easy. One of my answers comes up to be 0 divided by 3, which is 0. Remember, it's okay if I have 0 in the numerator, but if I have 0 in the denominator, that fraction is undefined. I'm going to add 3 to both sides here, so my second answer is positive 3. And if this is not factorable, I have a problem. And I know that it's not factorable because I said we can't break it down any further when we're doing cube problems. And because this is an easy trinomial, if it was factorable, there should be some numbers that I could multiply together to get 9, but add together to give me 3. There are no numbers that multiply together to give me 9 and add together to give me 3. So remember that if something is not factorable, a quadratic that I'm trying to solve, that I can use either completing the square or the quadratic formula. So let's use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2 times a. So in this problem, b would be 3. A would be the number in front, that's going to be 1. And C is going to be 9. So let's plug it in. Negative 3 plus or minus the square root of 3 squared minus 4 times A times C over 2 times A. So we get negative 3 plus or minus the square root of 3 squared, which is 9. Negative 4 times 1 times 9 gives me negative 36 over 2. I'm running out of room. So this gives me negative 3 plus or minus the square root of negative 27. That's 9 minus 36 over 2. So if you think about it, I got to simplify up under that radical. 27 is 3 times 3 times 3. I also have a negative up under that square root, which is important. That's going to make this an imaginary number. So to simplify this, I'm going to, anything that I have 2 of, I bring out. So I'm going to bring out a 3. The square root of that negative becomes I, and that leaves a square root of 3 up under the radical. And all of that is divided by 2. And remember, when we're doing complex numbers that has a real part and an imaginary part, we write it in the form of a plus bi. So this is 2 answers down here. Negative 3 halves plus 3 halves I square root of 3. And negative 3 halves minus 3i square root of 3 over 2. And then we have our third and our fourth answers here. So that one is a little bit tough in that when you have a cube problem, always remember that that trinomial will not be factorable. You're going to have to use something like the quadratic formula to be able to solve.